Hello viewers, in today's class we are going to discuss one important definite integral, right? And here we'll solve this definite integral using some important trigonometric identities, right? Basically what we will do here, we'll make use of the important trigonometric identities to simplify this integrand, right? So let us start. So here we are given the definite integral. Let us consider the indefinite integral of this integrand, right? So let us call that indefinite integral by I1, right? So here we have d theta over 1 plus sine theta plus cos theta, right? So once we'll find out the value of indefinite integral, we'll substitute the corresponding limits to get the value of this definite integral, right? So here let us first see the form of this integrand, right? See, whenever we have an integrand like say 1 over a plus b sine theta plus c cos theta, right? And similarly, if we have 1 over a plus b sine theta, or if we have a plus b cos theta, or if we have 1 over a sine theta plus b cos theta, right? So here we have four forms, right? And in all of these four forms, in the denominator, we have the combination of sine theta and cosine theta, right? Here we have the combination of sine theta and cos theta, and here also we have the combination of sine theta and cos theta. But in these two forms, sine theta and cos theta appears single, in a single form, right? So here we have only sine theta, here we have only cosine theta, right? So whenever we come across with such forms while integration, then what we do, we take the substitution, right? So here I will substitute at say t is equal to tan theta over 2, right? So in all these forms we can utilize this substitution, right? That is t is equal to tan theta over 2. This is the half angle, right? And here we'll make use of the important identities connecting tangent theta and sine theta, and tangent theta and cosine theta, right? So we can write tan or sine theta is equal to 2 times tan theta over 2, 1 plus tan square theta over 2, right? So this is an important identity from trigonometry. Similarly, cosine theta can be written as tan 1 minus, we can write 1 minus tan square theta over 2 divided by 1 plus tan square theta over 2, right? And the tangent theta can be written as 1 2 tan theta over 2 divided by 1 minus tan square theta over 2, right? So what we have discussed so far, that is whenever we have these type of forms as integrand, then we always prefer this type of substitution, right? So we take t is equal to tan theta over 2, right? So here also we'll take t is equal to tan theta over 2. So let us differentiate both sides, right? So when we differentiate both sides, we'll get dt over d theta is equal to half of secant square theta over 2, right? So we have differentiated t with respect to theta. Now we can write half, and sec square theta can theta over 2 can be written as 1 plus tan square theta over 2, right? So again we have the identity, that is 1 plus tan square theta is equal to secant square theta, right? And see, here we have half 1 plus tan square theta over 2 can be written as t square. So here we have t square. So now we have dt over d theta as half times 1 plus t square. So d theta can be written as 2 dt divided by 1 plus t square, right? Okay, so we have got the value of d theta as 2 dt over 1 plus t square. So now let us express I1 in terms of t, right? So I1 can be written as integral, and for d theta we can now write 2 dt divided by 1 plus t square, and in the denominator we have 1. Then we have sine theta. Now see, sine theta is 2 tan theta over 2 divided by 1 plus tan square theta by 2. So here if we take tan theta over 2 as t, so we have 2t over 1 plus t square, right? So here we have 2t over 1 plus t square, and here we have cos theta. Cos theta can be written as 1 minus t square over 1 plus t square, because tan theta over 2 is t, right? So now we have here 1 minus t square over 1 plus t square, right? So now let us simplify this expression. So we can now write I1 as integral. We have 2 dt divided by 1 plus t square, and here we have 1 over 1. So we can write 1 plus t square plus 2t plus 1 minus t square, and then we have divided by 1 plus t square, right? Now see, this 1 plus t square and 1 plus t square get cancelled, so we are now left with 2 dt divided by here t square and t square get cancelled. 1 plus 1 is 2, so we have 2 plus 2t, right? So now we can write I1 as integral 2 dt divided by, we can take 2 outside or common, so we have 1 plus t, right? Now 2 and 2 get cancelled, so we are left with dt over 1 plus t, right? So by virtue of this substitution, we have simplified this expression in terms of t to a very simple integral, right? Now the integral of 1 over 1 plus t is simply a log of 1 plus t, right? And here we have the constant of integration, right? So now I1 is equal to a log of 1 plus t can be replaced by tan theta over 2 plus c, right? So viewers, this is the indefinite integral of this function, that is 1 over 1 plus sine theta plus cos theta. Now we have to find the definite integral of this function, that is 1 over 1 plus sine theta plus cos theta. So what we will do now, I can be written as, we can take this integral as I. So we can take I is equal to I1, and limits are from 0 to pi by 2, right? So I1 is a log of 1 plus tan theta over 2, and here we can neglect this constant of integration, because once we substitute the limits, then this constant of integration get cancelled, right? So we have 0 to pi by 2, right? So now when we take pi by 2 here, theta is equal to pi by 2, we'll get log of 1 plus tan pi by 4, right? And then we have log of 1 plus tan of 0, right? So tan pi by 4 is 1. So we have tan 45 degrees is 1. And here we have log of 1 plus 0, right? Tan 0 is 0. So here we have log of 2, and this is log of 1. Log of 1 is 0. So this is log 2 minus 0, that is log of 2, right? So the value of this definite integral is equal to log of 2, and here the base is e. So we can also write this as ln 2, right? So viewers, this is how, by making this substitution, we can evaluate this integral.